This time, I'm going to talk about object detection with Tensorflow in Python. Object detection is a computer vision technique for locating instances of objects in images or videos. Object detection algorithms typically leverage machine learning or deep learning to produce meaningful results. When humans look at images or video, we can recognize and locate objects of interest within a matter of moments. The goal of object detection is to replicate this intelligence using a computer. In this video, I'm using the dataset from this website. You can download this data for free. This dataset contains 1,510 images belonging to two classes. One is the human face with mask, labeled with 0, and another one is human face without mask, labeled with 1. For each image file, there is a text file with the same file name but different extension. In this text file, we will have a class ID to indicate if the person has a mask or doesn't have a mask. And also, there are 4 floating numbers to indicate the location of the face. Now, let's take a look at our data set. You can see there are many files here, and for each image file, we have another text file with the same file name, but different extension. And if we open one image file, this is 149, and you can see there is a human face here. And if you open the text file, it shows first 1 means no mask, and then this is the center of X and center of Y, and this is width and this is height. In some other images, you can see there are many faces here. In this image, we can clearly see at least 1, 2, 3, 4, 5. And if we open the text file, you can see there are 5 faces here. In this model, we are going to drop all those images because we only want one face in one image. Now, I'll prepare the images for my model. I will convert all the color images into black and white, and also I will change the size of the images. The images are formatted to fit a 244 times 244 black frame. Object detection is a combination of 2 tasks. 1, regression of the bound box coordinates. 2, classification of the object label. This means that our model has 2 outputs, namely the object label and the object bounds box. Therefore, the model must combine the tasks of classification and regression. Now, let's take a look at loss functions for those 2 tasks. One for the classification task, we may use any loss function usually found in only classification tasks. One, for the bound box regression, we can use a regression loss function such as mean squared error. Now, let me explain the most important function for feature extraction. This feature extractor function is a sequential model. The curved 2D layer performs a convolution operation on the input data, applying a set of filters to extract relevant features. The average pooling 2D layer divides the input into non-overlapping rectangular regions called pooling windows and computes the average value within each window. You might have noticed the numbers of the filters kept increasing in the function from 16 to 32 and then to 64. By increasing the number of filters in convert 2D layer, the model can learn and capture more complex and abstract features from the input data. For example, when you define and convert 2D layers with filters equal to 32, it means that the layer will have 32 different filters. Each filter will learn to extract different features from the input data. The subsequent convolutional layers with 32 and 64 filters use the output from the first convolutional layer with 16 filters as input, and this input still contains the details of the features learned by the previous layer. The dropout function is a regularization technique used to mitigate overfitting in neural networks. Now, let's take a look at the results. This is the results for classification loss and bounding box loss. This blue line stands for the result for the training set, and the orange line stands for the result for validation set. You can see in this classification loss, when the epoch is over 10, the classification loss for training set decrease, but in the contrary, the classification loss for the validation set is increasing. Therefore, the classification loss clearly shows a system in overfitting. When we check the result for the bounding box loss, you can see the loss decrease for both training set and validation set when we increase in the epoch. So the bounding box loss doesn't show overfitting. Now let me explain how do we calculate IOU, intersection over unit. IOU scores how well the predicted bound box overlaps the actual bound box. the area behind IOU is pretty simple. Compare the intersection and union area between the predicted and actual bound boxes by dividing the intersection by the union, as shown in the following image. So, for example, this area is what we predicted, and this area is actual area. We will calculate the overlap area and divide it by the union area. So, for example, if they are close, that's very good, and we will have IOU like 0.7. If they almost match exactly, and we will have IOU 0.9. If the predicted bound box and actual bound box are not consistent, we are going to have IOU like 0.4. Now, let's run our model and check out our results. I ran my model in Colab. You can sign up for a free account and do the same thing. First, I upload the data file here, and then I put my model here. I'm going to upload the source code to my GitHub, and you can download the source code and run the model by yourself. You can see this is one sample data. It shows one female with a face. And you can see after I prepare my data for my model, I will do some padding and convert the image into black and white, and then you can see this is from the text file, shows the given area of the face like this, and you can see I use model with all those layers, and you can see the result of the model accuracy with the epoch increases. Both the training set and validation set increased, but the validation set reached maximum around 10 epoch. And then you can see this is the classification loss. You can see this is similar to the result I showed in my slide for the classification loss, but a little bit different. Of course, when you run your model, every time you will get a little bit different result, but it still shows overfitting in the system. And for this bounding box losses, you can see it shows similar result as I showed in my slide. And now let's check the result. We use IOU to evaluate our result. If we take a look, this is a pretty good result. You can see the IOU is 0.8882, and you see the predicted area and given area overlapped. Now let's find out the worst IOU score. is this one. It has IOU score only 0.0834 because this person's face should be here, but our model is telling it's here. Of course, over the time, our machine learning model will improve the results. This is how you can do object detection with Tensorflow in Python. Please provide your comments and subscribe to my YouTube channel. Thank you so much for watching.